Okie dokie. Let's try our next problem. Once again, we're finding all solutions. Find all solutions on the interval. All right, we're going here 0 to 2 pi again. Sorry, it's on an angle. Now, here we have a square. Okay, and it's tangent, so we have to do a little bit more work in this one. But once again, we realize our b value is greater than 1. We're going to have multiple solutions. And actually, if you, we'll talk about this, but what we might figure out is that if you take this number and multiply by the number of solutions you have when you solve for x, that's actually be the number of solutions that you will actually have there. So, yeah, that's what you have. So round to the nearest whole number for that one. So that's what we're going to check out. So let's, without further ado, let's do this. So here, we're going to take this, and we're going to actually take the square root. So we're going to have tangent of 3x, and we're going to take the square root of 3 to get rid of the square. And then we have, remember, plus or minus. And so now we're going to take the inverse tangent of plus or minus the square root of 3. That means we have both positive and negative. So when we solve for x, and we solve for this trig function, if I do our little thing, we know that we have a positive, negative. Well, tangent is positive here and here, and negative here and here. And what we have then is we have one there, and we have one here. And you could, if you're trying to find all the different solutions, you could find all four of them, or you can make this a little bit easier on yourself, because if you realize that this right here, we're following this one, so we'll first figure it out. So tangent is opposites, so this would be square root of 3, all right? And this can be 1, and this can be 2, and then we have this one over here, it's going to be, all right, square root of 3, okay? This can be -1, square root of 3, and 2. And so what we have, because this is in all four quadrants, if you saw some past videos, I'm just solving for multiple solutions for x, we know that we can just simply take the first and second quadrant one and add a pi n to it. Okay, add pi n. So we're using our knowledge of knowing that this angle and this angle are just pi n away. So when I set this up, I'm going to go 3x equals, well, what's this angle? Absolute square 3, we should be very popular with this one. Pi over 60 degrees, which is pi over 3. I'm going to add pi n. So that will give me this angle, just so everybody knows, by just adding pi n, that gives me this angle, and it gives me that angle, which is going to be pi n units away from it. We go one more, so this is a shortcut. 3x, only can do this when you take the square roots, plus or minus, only with 4 of them. All right, what we have right here is we can take this one, I'll change the color to red, so we find this one, which we know is going to be 2 pi over 3, and we can find the other one right there by taking a pi, so we're just going to add pi n, and then we take another pi, and then another pi, and so on and so forth, so that is going to be our next one. Okay, so these are our various ones. Now, I told you a different shortcut. If you have 3, we actually have 1, 2, 3, 4 solutions multiplied by 3. So if you take 4 possible solutions multiplied by 3, we should have 12 solutions. All right, guessing 12 solutions. Ooh, wow, it's going to be a lot. All right, so 12 solutions. So with that, my friends, we're going to find these solutions. But before we do, we have to solve for x. Remember, we have to solve for x. Solve for x. And so in order to solve for this x in this one, we're going to divide by 3. In order to solve for x in this one, we're going to divide by 3. And what we have then is this is going to simplify to x equaling pi over 9 plus pi over n over 3. And then right here, we're going to have x equaling 2 pi's over 9 plus pi over n3. So now we're going to find all solutions on interval, apologize, interval 0 to 2 pi. Now, if you want to change this, once again, our denominator is 9. So it'd be 0 to 9 over 18 pi. That's what we're looking for. We're guessing 12 solutions. How do we get that? We took there's 4 possible. All right, times 3, and that equals 12. And that's how we get that one. Just for a little guess. If you're confused by that, I'm just gonna erase that because I'm gonna put these notes on board and I confuse some students. All right. Well, in any case, what we're gonna do now is from here, we're gonna find all our solutions. So we're gonna go n equaling 0. There's gonna be a lot of them. N equaling 1, n equaling 2, n equaling 3, n equaling 4. I'm gonna go up to n equaling 5. Okay, 5. So from here, let's check this out. Well, we're going to start with when x is 0, so it's going to be pi over 9, right? And then x is going to equal 2 pi over 9. Might see a pattern right developing pretty quick. We're going to change this common denominator, so it's going to be 3 over 9. 3 over 9 when we're going and doing this. So next ones, we plug in 1 in for n. And so we have is 3 pi's plus 1 pi is 4 pi over 9. We're going to plug a 1 in here. 3 plus is going to be 5 pi. 5 pi over 9. Go to the next one. 2, 6, 7 pi over 9. Plug in a 2 into there. 5 plus 2 in here. It'd be 6 is 8. Yep. 8 pi over 9. You might see a pattern developing. These are right there, right? 1, 2, 4, 5, 7, 8. And what do you think the next one's going to be? Not sure. 9, 10 pi over 9. This is going to be 11 pi over 9. Pi over 9. Yeah. Do you see the pattern? Went odd, even, odd, even. This one's probably going to be odd, yeah. So if you're guessing, if I'm a betting man, probably gonna be 13. We'll see what it is. Put 4, 4, 12, 13. Yeah, 13 pi over 9. Right there, it's gonna be 14 pi over 9. Remember, we're gonna get up to 18 pi, so we're getting pretty close. So one more, 5. 5, we're gonna go odd, even, odd, even, odd, even. So if you had to guess, it'd probably be 16 pi over 9. Just to verify, put in the 5. 5 times 3 is 15. 15 plus 1 is 16 pi over 9. And this is going to be 17 pi over 9. We are done. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What do you know? Bada bing, bada boom. These are our solutions, 12 of them, just like we guessed. All right, and these are all the solutions that we have here. Okay. Once again, I know some people are saying, well, why don't we use 2 pi right there? Don't need 2 pi because once again, just in the previous problems, whenever you're adding and subtracting, you're creating 4 different quadrants. If you find the first one here, this one's going to be right there. So it's only going to be, we're moving at pi units. So to make it a little simpler, we're going to take the first 2 and just add pi n to them to help us find out all the regular solutions. You can put this in your calculator to verify. I'm not going to do that right now to save time, but that's what we have for our answers. Okay, I hope this helps. And yeah, if you have any other questions, check out some other videos. All right, thanks. Good luck and God bless.